We had previously explored the automatic routing techniques in Revit using the generate layout and generate placeholder tools. While the tools can save you some time, it is imperative to master the manual routing techniques in Revit as a mechanical engineer or modeler. In this video, we'll connect the fan coil units with the plant equipment by manually routing the pipes. So start by opening the file you used in the previous video or manual routing in the chapter 3 exercise files folder. So at this point, launch Revit, navigate to the exercise files from the chapter 3 folder. Open this file, manual routing, which I have here, open. Then open the ground floor HVAC plan. You notice I've used detail lines to draft a guide layout for the pipe routing. Next, launch the view range dialog for the ground floor plan. From the properties browser, I look for view range, then edit it. Then make sure to set the bottom and the view depth level to unlimited so we can see the pipes running under the ground as we lay them out. Now, if the view template controls the view range, you want to go to the view template and remove it from the template by unchecking it here, so it doesn't affect other views that are using the same template, because if you edit the view range from here, it will also affect the other views. So after that, select the duty chiller in the plant room, then click the hydronic supply icon to create a pipe, then draw a straight pipe run. Make sure to set the pipe type to chilled water from the properties browser. So after drawing the first run, change the middle elevation to minus 900. So by the time you draw the next pipe run, Revit automatically adds a vertical pipe segment and necessary fittings to connect all the pipes. And then we'll continue to run at this level. So we're using minus 900 because we want the pipes to be minus 300 millimeter below the natural ground level, since the ground floor is 600 above the natural ground level. So we run at this level until we get to the pipe chase or the entry into the building, which is at this point. So next, we want to change the middle elevation to 7,300 millimeter to take this pipe all the way to the first floor ceiling. So we'll click this and then we'll click apply on the options bar. Now, if you notice, Revit has added a vertical pipe. You can also switch to the 3D view to see what we've just created. So now you can see that pipe. You can see it comes out from here, go into the ground, and then run all the way to the first floor ceiling. So when routing HVAC systems in Revit, space planning within the ceiling is paramount. For this project, we have about 700 millimeter inside the ceiling above the ground level. So this ceiling here, between the ceiling and the floor here, will have about 700 millimeter, which is quite generous. So since multiple disciplines coordinate in a typical project, the design team should decide early on the middle elevations for the various duct and pipe systems to minimize clashes. For example, in this project, we decided that the ducts will have middle elevation of 3.5 for here, and this is 3.8, and then the pipes will start about 3.1 for here, and everything will be below the ducts. For this one, it will start about 3.4. So this is all about planning. The team needs to plan to make sure that the system does not clash with each other. So next, we'll go to the ground floor. Then we'll right click this pipe and create similar. You can also just type PI to create a new pipe. Then you set the diameter from here to 25 millimeter and the middle elevation to 3.1 based on our ceiling planning. Now we need to draw out the branch pipes that will eventually connect into the fan coil units. So making sure that I have the diameter and the middle elevation correct, draw out all the main branch pipes. So these are the main branches. Of course, we need to connect this into this here. You can use the extend trim command to do that. If it doesn't work, you might do that from a 3D view. So I can go to a 3D view and trim it from there. So when I trim this, it should automatically add the fitting like this. So you can see what that looks like. So now I'll go back and do the final connections into the fan coil units. For this, I want to use 15mm for the final connections. So I can also right click or just type PI to launch the pipe command. And of course, it's still at the same middle elevation. I need to set this to 15mm. So I draw the final connections all the way to here for the various pipes. For this one, I switch this to a T, which we'll talk about in a future video. Then I continue from here all the way to here for now. So now it's remaining the final connections into the fan coil units. There are two ways to go about this. You can select this fan coil unit and use the connect into tool. You see you can have multiple connectors. So you want to know which particular one. I want to connect from the chilled water supply connector, and then you can specify the pipe to connect into. So by the time I select this pipe, Revit automatically completes that connection for me. So you see that. Second way is I can actually draw it out from the component the same way we did for the chiller here. So I can come to this fan coil unit and I click on this icon. Because you have two pipes above each other, two connectors above each other at that point, you still need to specify which of them. So I'll still pick chilled water from here, and then I draw this, then go and touch this particular pipe here. If it does not touch, because I have a line there, I can just use the trim command to join it, trim extend command, and you need to make sure that you see this fitting at that point. So I prefer to do it this way because it gives me more control. So I can just connect out of all of this and then connect into the respective pipe. So because we already configured the pipe size from that connector to be 15mm, that's why everything kind of matches. So you need to select the mechanical equipment and also make sure that the radius for the connectors are properly set. So I'll do this for all the fan coil units on this level, then I proceed to the first floor. If you also notice, the pipe placeholder here is not showing because we disable it from the visibility settings inside the family. So if you need that to show, you need to open the family and enable it to appear on ground floor. So we've connected all the fan coil units on this floor. So next we will proceed to the first floor. So from the first floor, we need to branch off from the vertical pipe, which is this one here. So this is where it enters. So just type PI. Now we need to set the diameter to 25mm and the middle elevation to 3.4, which is our middle elevation for this system on this floor. Then we'll quickly create the main branches as well. So I go this way. Now the main branches are at 25. The final connections, we want to set them to 15mm at the same middle elevation. Always make sure that there's a fitting connecting the two pipes. So now the final step is to connect out of the equipment to finish the loops. Always make sure that there's a fitting connecting everything. So now we've connected all the fan core units for this system. To confirm that I have everything, I can use the tab key to select until I select the entire system. Then I can filter this to make sure that I have 12 mechanical equipment. Okay, the reason is because we've not connected into the ground. So we come here, can use the trim command to trim this and this. Now everything has joined. So now if I use the tab key to select everything this way, then if I filter this, I should have 11. So one is not yet connected. So these 6 are connected. On the ground, this one is not yet connected. So I need to make sure that everything is properly connected. So here I can just right click, create similar. So you see this is 3125. Now I need to set this to 15 millimeter. This is the final branch. And then I connect from the equipment. Into this. Now I can check again. If I filter this, I have 12 mechanical equipment, so 11 fan core units and the duty chiller that we have currently. Now when you finish the chilled water supply pipe layout, go to this parent equipment and check the water flow value. And you select this and you scroll all the one all down here, you see that the chilled water flow has populated, and this is the sum of all the child components that are under this. Now to show you an interesting thing, if I go to the report that we generated earlier and I go to the equipment sizing summary, the component sizing summary rather, and I go all the way to this chiller, the sizing that was specified through the analysis we did earlier, you can see the chiller. And now this is the same flow rate. This is the meter cube per second. If you convert this to liter per second, this is actually 1.174. Now what we have currently in the project is 1.16. So that's as close as it gets. So this to show you that the system analysis is actually very accurate. So it has already given us an idea of the size for this particular equipment. So as a final step, we will extend this into the standby. So we can quickly do that. We change this to 80 and then we'll create similar. Confirm that this is at minus 900 and this is 32. So we'll draw this and this, and then we'll complete the connection from here. And use the trim command if that doesn't work. So now we've completed the chilled water supply. We now have a closed loop combining all the equipment. We have only laid out the chilled water supply piping network. We still have chilled water return, hot water supply, and hot water return. But you've seen how to route pipes manually. So use what you've just learned to lay out the other 3 systems. Use the completed file in the chapter 3 exercise files folder as a reference.